Hi friends, this is Onindo, your physics friend. Today, let's play with Kirchhoff's law. What are these two laws? First one is junction law. At any junction, the algebraic sum of currents is equals to 0. And the second one is loop law, or loop rule. In a closed loop, the algebraic sum of potential differences across all circuits elements is equals to 0. So you can explain that by some examples. Suppose we have a junction, one is incoming, another 2 or 3 are outgoing. So suppose incoming current is I0 and outgoing currents are I1, I2 and I3. We can say if you denote incoming current the direction I0, that direction is positive, then others will be negative, then minus I1 minus I2 minus I3, that will be equals to 0. Okay, so now loop rule. Suppose we have a loop having a battery and some resistances. Add them. We plus minus R1, R2, R3 say, and suppose the current through that circuit is I, then voltage difference or potential difference or potential drop through R1 will be IR1, R2 will be IR2, R3 will be IR3. So finally, according to Kirchhoff's voltage law, or we can say KVL, Kirchhoff's voltage law, according to that law, V minus IR1 plus minus IR2 minus IR3, that will be equals to 0. So these are the two rules. Let's check out some problems, or some numerical problems. Okay. We have a new circuit. At the first glance, you may consider that that one is a Wheatstone bridge, but unfortunately this is not. This is a simple word connection. So let's redraw the circuit. Oh, I forgot to mention the question over here. The question is, you need to find out the potential difference between A and B, or better to say VB minus VA. You can simply understand that that can be find out by just finding out the current through the resistance R3 and multiply that with R3, and finally you will get that the potential difference between, not the potential drop on R3. I repeat, if you find out the current through R3 and multiply that with R3, you will get the potential drop on R3, which is actually B, and in between B and A. So let's redraw the circuit. That will be like, the first one is E2, start with that one, then we'll have a junction A. At the negative terminal we have to add R2 resistance, and from A to R2 we have another resistance which is R3, and that terminal is B, and at last we have R1 and we have E1. Plus minus plus minus. Now let's mark the current through that one, through that branch. Suppose that one is I0. Suppose from node A, suppose this in this direction the current is I1, in this direction suppose the current is I2, say, and I1 will go through, will come through that way, and finally will be added to junction B, and from B to the negative terminal of E2 will get the current I0 again. So I0 just leaving the junction, I0 entering the junction. I0 is leaving the positive terminal and I0 is entering the negative terminal. Well, to solve that type of problem, we need to go for both loop analysis and node analysis. So then point out the loops. Then first loop, loop 1, second loop, loop 2. And the beauty of Kirchhoff's law is like you can take the direction of current arbitrarily, because suppose I0 and I1, you will get I0 and I1 as positive as per my consideration. If these are positive, then the direction will be from left to right. But if you get the value of I0 and I1 are negative, then you'll just have to change the direction of the current. So I1, suppose I1 comes negative, then I1 will be directed to from my right to left. Okay. So let's check out the first one. The first comes from Kirchhoff's current law, KCL, that gives you what? At that node, if you consider I0 is entering and I1 and I2 are leaving, so I0 that should be equals to I1 plus I2. And the second equation comes from KVL, which gives you, if you apply that on loop 1, that gives you E2 is equals to I2 R3 plus I0 R2. I'm so sorry, I don't. Suppose that one is equation 1, that one is equation 2. The next equation will be formed from loop 2, which will be, suppose I1 R1, the voltage drop across that. Then we have plus E1, and then we have that branch. Okay, so that will be negatively I2 R3. Why negative? Because the direction is at the downward. If the direction was just to the upward, then we have to add that. Okay, so that will be equals to 0. So suppose that one is equation 3. So to solve that problem, we need to find out, suppose we need to find out the I2 from that equation. So if you just solve that equation, by simple algebraic method, you have three equations with your in your hand. You have three variables, I0, I1 and I2, and if you solve that equation, you will get I2 equals to E2 R1 plus E1 R2 divided by R1 R2 plus R2 R3 plus R3 R1. Now to find out VB minus VA, you just need to multiply R3 I2, which is actually the voltage drop across that branch. So finally that will be VB minus VA R3 multiplied by I2 E2 divided by R2 plus E1 divided by R1 divided by 1 by R1 plus 1 by R2 plus 1 by R3. This is the final answer. of our final target. You can solve these three equations using Cramer's rule also. In my next tutorial, I'll surely show that. Oh, let's check out another problem. We have a circuit again. We have a voltage source or a battery. We have few resistors connected like that. Now we have to find out the voltage difference between A and B. Oh, that circuit connection. Well, you can see that that portion, if you redraw that portion only that portion, you'll get a 2 ohm resistance, a 5 ohm resistance, and you can see that 2.5 and 5 are connected in series, so you can just add a 7.5 ohm, just replacing by these two, and then we have suppose 3 ohm resistance, and between them we have another 2.5. Now can you recognize that? Wow, that one is a Wheatstone bridge connection. Simple. 5 by 2 will give you 2.5. 7.5 by 3 will give you 2.5. So no current will pass through that one. Wow, that's good. So let's check out. So let's redraw that total circuit. The total circuit will be a simple one. 10 volts plus minus 10 volts, which is connected to 2.8 first. Then that will be connected to terminal A, negative one, terminal A. Then suppose this is our equivalent, terminal B, and you have to find out the voltage difference between A and B. And now R equivalent you can find out from that circuit. That circuit can be drawn as 2, 5. We can just omit that one because this is of no work and no current pass through that one, so you can just cut that one. Oh, 3 ohms, 7.5 ohms. So that will give you roughly 4.2 ohms. How? Simple. 2 plus 5, that will give you 7. 3 plus 7.5, that will give you 10.5. So 10.5 multiplied by 7 divided by 17.5. You can find out that from that equation. So just replace that. R equivalent is equals to 4.2 ohms. Now you can find out the voltage difference between A and B. You can apply Kirchhoff's voltage law, but I'd like to apply on voltage divider rule, which actually says voltage across a resistance is actually the total voltage multiplied by the resistor divided by the total resistance. I repeat, voltage across a resistance, suppose VAB, we need to find out voltage across the resistance A and B. Voltage across the resistance are equivalent. VAB is equals to total voltage of V, and which is actually 10 volts, V total, multiplied by that resistance R equivalent divided by the total resistance, which is actually total resistance is 2.8 plus R equivalent, 2.8 plus R equivalent. So that will be equals to 10 multiplied by 4.2 divided by 2.8 plus 4.2. That will give you what? 10 multiplied by 4.2 divided by 7, that will be 6 volts. So my final answer, VB minus VA is equals to 6 volts. Today, that's it. And please like and subscribe my channel for more videos, for more tutorials. Till then, me, Anindamandal, signing off.